Welcome to the experiment on resistors in series and parallel. I've already gone through several of the things that you'll need in order to build these circuits in lab for those in series and parallel, and then I left a question to you about how to build that combination circuit in the most efficient way possible. There are only a couple of things that I want to show you here. The first is the switch. Now you may or may not have to use the switch. You should ask your instructor. This is called a double pole double throw switch. And a double pole double throw switch is used to reverse the direction of the current. We're not going to be using that feature of it just yet. We'll use it later in the semester, but I want to go ahead and introduce it to you now. The way that you'll use the double pole double throw switch is that you'll have your wires connected on two terminals. You'll have a terminal here and a terminal here. And then if you look at this, you'll see that the current can flow through the brass tabs on the side of this. Then if you want it to be off, you move the switch in this direction. If you want it to be on, you move it in this direction. And again, you're only connecting to two terminals. Although you'll see on this switch that there are actually a total of 6 terminals. Later, when we look at magnetic fields, when we explore that idea, we'll use the double pole double throw switch for its intended purpose, and that is to change the direction of the current. By the way, this is the kind of switch that you often see in movies where they're trying to make, I don't know, Frankenstein, or have the big switch that you pull down and you move down in the opposite direction. That's really a double pole double throw switch, and that's what we're using in the lab today, but only for a simple switch where you only connect the wires to these two terminals, and then off, on. Your instructor might just tell you to turn your power supply off or on at the actual switch for the power supply, and that's okay too. But the important thing is that when you set your terminal, your voltage on your power supply, is that you keep it on that voltage, and when you're not using your circuit, you just turn it off, and then when you're ready, you turn it back on again. Okay, the next thing I want to show you is how to measure the voltage and the current. And we've done this somewhat, but I just want to make sure that we're clear on this. So if I have a resistor on my board, so there I have my resistor on the board. If I want to measure the voltage, I take my voltmeter, and here I have the banana plugs on it. I take my voltmeter, and then I can just take the banana plugs and I can put them right here to measure that voltage. Remember, voltmeters are hooked up in parallel. And so if I do that, I can connect, or if I have alligator plugs, I can connect them onto the ends of the wire, or I can just touch the connectors onto the leads of the resistor. That will measure the voltage, and that will always work, whether your resistor is hooked up in series, parallel, or combination. Now, if I want to measure the current, the easiest way to do that, and the way that will always work, is to just do it on your board. So take your resistor, if you have a single resistor, and move it into the diagonal portion of the board like that. Now, this is now an open circuit because current comes in here, goes through the resistor, and then it doesn't have anywhere to go from there. But if I'm using my ammeter, take my ammeter, and I place it in series with the resistor. Remember doing red to red, black to black, or current flowing from red to black. And now what happens is my current comes in this terminal, it goes through the resistor, it goes through the ammeter in series, and then back out here to the rest of the circuit. So that's the easiest way to measure current in one of these circuits. And again, that will work for all 3 of your circuits that you'll be building today. You will have a calculation portion, so when you come in, you can go ahead and do those calculations. In fact, I urge you to go ahead and do those calculations now so that you'll have plenty of time in lab to do the building the circuits. So go ahead and do those calculations. That is the analysis section, parts 1, 2, and 3 for your lab. And then when you come in, you'll only be doing the measurements, building your resistors in series, your resistors in parallel, and then also your resistors in combination. And then finally, once you get those measurements, you'll compare them to the calculated values that you had for the current and the voltage through each of the resistors in each of the different circuits. It's a great lab. It's a great practice area for you to practice for the class, and you'll probably be building some of these circuits for either your midterm or your final.